start doing we're going to start going through the adding, subtracting, and multiplying. Guys, we're going to start going through the adding, subtracting, and multiplying of all polynomials. And as we go through this, periodically we'll show you guys the reasons why we do certain things the way we do. Because it all builds into what we'll do more than likely towards the end of next week. Now, earlier this week, I had been talking about doing the short quiz and all this stuff tomorrow. Now, normally what I would do would work out fine, but I'm starting to think that it might not be the best spot. So what we're going to do is we'll wait, and I'm going to do it. It looks like from looking at my scheduling and looking at pacing of where we're at, my best guess is that it'll wind up being probably next Wednesday. Okay? And that'll be 6-1 through 6-4. That'll allow us to do a little bit more work. What we're going to look at today is the quick adding, subtracting, multiplying. This is nothing new. There will be a couple of newer special product rules that you will see. What's nice about those is that they work. But do you need to use them? No. But it will help you later on with factoring. And that's what I'm getting at for tomorrow. I know a lot of you guys won't be around tomorrow. And I'm going to start factoring via grouping, which is a method that you have seen. It's basically doing GCFs twice. So it's just going to be using it with higher degree polynomials. So if you're not going to be around tomorrow because the videos or the movie and whatnot, you'll just watch the video and just be responsible for it for come Monday like we would normally. It won't be that big of a deal. It honestly isn't difficult, so just so you guys know. Then on Monday, between Monday and Tuesday, we'll continue to work more on some of the first step of factoring, as well as reviewing some of the exponent rules, because believe it or not, we can make them look pretty gnarly, which is pretty cool. So I'll throw some of those together. We'll do a little bit of review chunk on Tuesday, and then we'll go quiz 6-1, 6-4 Wednesday. And that'll get us next Thursday, Friday to start going through why in the world synthetic division is your best friend. And it all stems from basic stuff here. So when we're talking about adding and subtracting between those two, I know that all of you guys have done this before. Adding and subtracting polynomials together is absolutely nothing more than combining like terms. Now, one thing I want to show you is that textbooks generally write out things in terms of horizontal. My guess is maybe to save space. I really don't know. Whenever I do adding, subtracting problems, I'm always going to write things vertically. So when I read a problem like this, which most of you guys are doing right now, I would write the first part, 3x cubed, 2x squared, minus x, minus 7. That's a third degree polynomial, which means it should have 4 parts to it. Does it have all 4 parts? Yeah. So I have to put a placeholder. So I would write down, if I'm reading this in a page in my book, in my mind, I would write it like this: 3x squared, or 3x cubed, excuse me. Move it over a little bit, 2x squared. Move it over a little bit. There's a reason why I space it out, and you'll see it here in a second. And then what I do with the second part is I line up everything vertically. Most of you guys, if not all of you guys, probably learned how to add vertically. It was the easiest way to do it. Okay, it was super simple. Just line it up. X cubed minus 10x squared plus 8. And what I'm doing there is I'm creating 4 quick addition problems. Now, do you have to use this method? Absolutely not. Is it a method that takes an extra second or two to do? Yeah. Does it also slow your brain down a second or two? Yeah. And these are things that are super simple for students to do, especially for you guys. You guys fly right through this stuff. But you'll miss a sign. You'll say 4 plus 2 is 8. You'll do something dumb like that. By spacing this out, putting the addition symbols between all those parts, it just forces you to slow down. Okay, it's an air brake. So what's 3x cubed plus an x cubed? 4x cubed. Okay. 2x squared plus a negative 10x squared. Negative x plus 0x. Negative 7 plus 8. Again, nothing that you haven't seen and or done before. I know all of you guys have done that, right? Descending order, remember what that is? Highest degree, work your way down. If by chance you had no x squareds, do you have to put 0x squared? No. No, you can just leave it blank and just go on to the next thing. You don't have to put placeholders in your answers. If you do, are you wrong? No, you're just wasting pencil lead or ink. It's not a big deal. This is just, like I said, the stuff that we're looking at today is quite literally the easiest thing that we do throughout the first semester, and I hope you're with me on that. Well, trig. Trigonometry is awesome. I love teaching trig. Dance moves. Trig. Probability statistics. Probability statistics is the easiest for you guys to do. Usually, when we get to the probability part and the statistics, it winds up being something that's interesting, and yet it's still new for the stuff that I show you guys, that you're like, oh, this is kind of cool, and you actually put a little bit more effort into it, and I see this year after year. When you get to something that seems kind of cool, that you kind of enjoy, you do better at it. I mean, exponent rules, yes, they're pretty easy, but with something with a tinge of a challenge, you're like, oh, yeah, and it's still kind of neat. But usually people do very well. Same thing goes for subtraction. When I have subtraction, I do the same scenario. I write down my first step. I put things in if I need placeholders just to help myself out, and then I line everything up vertically. In this case, again, I don't have to worry about placeholders for the first part. It's squared, singular, constant. Let's write it out. Just space it out a little bit. Then I have a 3x squared minus a 6x minus a 1. And I know I'm subtracting between all of them. And it just creates 3 subtraction problems. Okay. I've always felt that most students do a better job when they see things vertically than trying to distribute the negative and then combine it like terms. It just gets to be a little bit messier than it needs to be. Okay. So, good luck. 5x squared minus 3x squared. Now you're stretching. All right. You need help? All right. So if you have 5 and I take away 3. Yeah! All right. Go away. 1 minus a negative 6. La puerta está aquí. I know. Negative 7 minus a negative 1. 6. Okay. Again, all I'm doing is we're just adding and or subtracting vertical. Usually when students see the stuff written out vertically, you guys do much better. Do I need to do any more examples of adding or subtracting? Okay. All right. I thought you were going to go. Yeah, that's fine. So, we'll do it another day. No, you know what I need? I need a spider. Oh yeah, here, go next door, guys, for the spider. Okay. Go. What's that? Put it in our chair. No, and I thought I know, and I just realized it. So we're not going to do it to anybody else. I just remember because I remember seeing Mr. Horn going down two doors down, and that's right where we would have hidden. And I didn't want to do that to another teacher who was being observed. Because that... Yeah. Oh, tank turned up. Oh yeah, the distractor. Oh, she'll still not. She'll forget. Oh wait, you're right. Oh. No, we're good. Yes, we're gonna multiply. Oh no! Yeah. Foiled again. Yeah, right. Curses. Foiled again. In this one here, we have a x minus 3, we have a binomial times a trinomial. When you have a binomial times a trinomial, there is no FOIL. What you have to do is distribute twice. I know. So when you distribute twice, it's really send the x to all three terms, send the -3 to all three terms, and then combine your like terms. Okay. Again, this isn't anything that you haven't done, but it is something that you'll make a dumb mistake on, Jackie. So when you distribute out, what's x times 3x squared? Didn't work as well as we hoped. Spider of shame, yes. Yeah, that's a great idea. Let me go get the spider of shame on. I should know the tapes. Spider. Steve. He's like a parrot, but not. It's a good look. There, I am something. Oh, you got caught my contact. Then I do it again. -9x squared plus 6x plus 12. Another thing that I've learned throughout the course over the years is when you combine like terms, again, we always put things in a descending order because that's kind of the standard way to write out polynomials no matter what. So you start at the top and work your way down. You've got your 3x cubed. And then what I usually do is I underline my next sets. All right, -2x squared, -9x squared gives me, you've done this once or twice. We go negative or not 2x, that's the question. And go on. Again, I was seeing if you guys were paying attention, congratulations. I do that on purpose from time to time to make sure that you are awake. Now, this is one of the things that I want you guys to see. I hit the next button twice. One of the things that I want you to see is that here we're going to multiply 3 terms together. Okay? Now, if we start going back to the idea of what our terms, what terms are. If x minus 4, x minus 2, x minus 5, if those guys are my terms, what are the zeros? 4, 2, and 5. Okay. So if I set this equal to 0, and this is hypothetical, this is what we're getting towards here in a little bit. That tells me I have zeros at 4, 2, and 5. You okay with that? What would the leading term coefficient wind up being with this one? Could you figure that out without too much of a hassle? That'd be 3x, it'd be x cubed. But would it be positive or negative? It's going to be positive. All right? So what I'm getting at here is if we FOIL this, if I distribute all this out, does it matter which two I multiply together first? No. Here's a suggestion. When you have 3 of them written together, do the last 2 first. If you do the last ones first, you can more often than not probably FOIL that in your head. You get x squared minus 7x plus 10. And then you can just send the front term to both of them, as opposed to getting x squared minus 6x plus 8 and then have to distribute going backwards. It's just a suggestion. Any way you want to do it is fine. All I'm saying is that one of the reasons why I'm setting these things up like this is because eventually we're going to start with a 0, write the term, FOIL it out, get the polynomial, graph it. And it all starts with the idea of these are terms, these are zeros. So distributing this then, we get x cubed minus 7x squared plus 10x minus the 4x squared plus the 28x minus the 40. You all right with that? Combine like terms, we have x cubed minus 11x squared plus 38x minus 40. Okay. It's a third degree polynomial. It can have up to 3 zeros. In this case, we know it has 3 zeros because we start with 3 terms. What are our dance moves doing? They're down up, aren't they? They're down up. And remember, if you have a third degree polynomial, how many possible changes of directions can you have? 2 of them. So you know that somehow, some way, well, negative 40 is down here. It's coming up, changing, going. You know that graph's going to look like that because you know the difference between a 0, a term, and how to dance. That's where all this stuff gets to. Okay? Okay? You go through that. Now, the other thing that's going to happen is that we're going to also be able to build polynomials and multiply things out. If I give you zeros, if I just say your zeros are 3, negative 4, and 8, you would tell me that my terms would have been and you could go through the whole process again, couldn't you? Now, what happens in about a week or so, we're going to do this also. A little bit more. Now, here's the thing. Just to get you into this, because I know how much you guys just all loved imaginary numbers. When you had an imaginary number, every time you came up with an I value, what did it always have? It had a positive and a negative, didn't it? Imaginary numbers always come in what are called conjugate pairs. So if there's a 2i, that means there had to be a plus or minus 2i. Okay? So knowing if I had something like this, that means it would be a third degree polynomial. And I'd only have 1 real 0, 2 imaginary zeros. It still has 3 possible zeros. But you have to think about how do you get to this? And we'll get to that. Also, we'll get to things like this. If you have a 2 minus I, that means you have to have a 2 plus I. We're getting there. This is why, guys, that's why we start with this, so you understand what a term means. I've been saying terms and zeros a lot. When we understand what a term is, we know what the 0 is, If we FOIL it out, we get our leading term coefficient, know our degrees, we know our dance moves, which way things are moving, and we can start to get the idea of rough sketching curves. That's where polynomials get us to. All right, we're getting there, baby steps. Which leads us, bless you. What does that mean? Okay. Now, we've done stuff before where it was junk squared. Junk squared was junk times junk. Junk cubed would be junk times junk times junk. Junk to the fourth would be, and then junk to the 0 would be, yeah, all right. That was great. Now, ladies and gentlemen, what I want to show you here is that there is going to be a couple of different ways to, when you have stuff raised to a third degree power, there's a couple of ways of doing this. You can, bless you, you can by all means go the long way and multiply it out. It's fine, you'll get there. Now, the advantage to learning that there are specific shortcuts helps out tremendously. It's going to help out a little bit more when you start factoring. If you've ever had to factor something that had a higher degree polynomial than 2, knowing what is called a sum of cubes or a difference of cubes, which I'll show you in a minute, by understanding the pattern that's there, it makes your life easier. For example, if we go back to the pattern of this, how do I factor that? What is it? It's x minus 5x plus 5. The two terms that create that, oops, what's that? Because if you multiply them together, that middle term went away. Is this a perfect square? Is that a perfect square? Is that a subtraction? That means that's the difference of squares. Okay. Now, same thing goes for if you had x squared plus 10x plus 25. What times what's 25 you add together to get 10? 5 and 5. So that pattern was, that's the same thing as saying x squared plus 2 times 5x plus 5 squared. Remember that? It's called junk squared. There was a special pattern to that. Most of you guys just spoiled it out and didn't have to worry about it. But there was a special pattern that occurred sometimes. It's the same exact style of an issue when you have junk cubed. Let me show you what I mean. When I have junk cubed, I follow this pattern. I'm just going to write it in terms of A's and B's. What happens here is that you have your first term cubed plus 3 times the first term squared, second term to the first power, plus 3, first term, first power, second term squared, plus the last term cubed. Now, actually, it's how you can FOIL out really any upper degree polynomial. And this, yes, sir. It comes from Pascal's triangle. Was it 1? As you work through upper degree polynomials, and we'll come back to this thing in about a month or so. What happens is the special patterns of things, of polynomials squared. Think about junk squared. This is junk squared. First term squared plus 2 times xy plus last term squared. Uh-huh. These are the coefficients that are put in front of everything else. The tails are always squared, squared, middle term 2 times the 2 put together. Cubed, cubed, 3 times the middle term, 3 times the middle term. But what happens with your degrees of the parts? 3, 2, 1, 0. B's. The B value starts at 0, 1, 2, and 3. They go in opposite directions of each other. And that's one of the ways as we get to upper level polynomials, we'll be able to figure out coefficients of things that are to the fifth power. What is the third term in the fifth of a polynomial raised to the fifth power? It's a whole thing built off of this. And we'll get to it. All I'm getting to is this is a special pattern that will help you later on. It also becomes really evident when we start factoring. And we're going to get to all that. So in this case here, what's playing the role of A? X. What's playing the role of B? 3. So I wind up with x cubed plus 3 times x squared, and then 3 to the first, plus 3 times x to the first, 3 squared, plus 3 cubed. All right? Instead of foiling it all out twice and combining like terms, it just so happens to be a faster process. What's 3 times 3? 9. What's 3 squared times 3? 27. Okay. That's what you're looking at for right now. We're not trying to make this any crazier than what it is. The idea is that there are two special patterns that we're looking at today. You've got the sum of cubes, and you've got the difference of cubes. The only thing that changes between the two is down a bit here. If I happen to have a minus b quantity cubed, it's still a cubed minus 3a squared b to the first plus 3a to the first b squared minus b cubed. It just goes, the signs just alternate. It's the only thing that changes. It's just one of those patterns that if you recognize it out, you can follow the pattern to make it quicker. Is it the end-all, be-all that if you use it or don't use it, it's okay. If you want to write it out 3 times and FOIL and combine like terms, there's nothing wrong with that. Yes, ma'am? Yes, for the minus, it goes minus plus minus. Yeah, the first term's always positive, so it's plus, minus. They just alternate through. It's just one of those things that if you recognize it, great. If you don't recognize it, it's okay. There's nothing wrong with it. So for just a quick example, I'm going to do one that's a difference of cubes, but I'm going to put a coefficient besides just an x in it. All right? I'm going to do this. Let's say we have 2x minus, I'm trying to make numbers so they're not horrible in cube. 4. No. What is the 2? We'll do 5. 5's not bad. Okay. And let's cube it. Oh, sorry, that's supposed to be b cubed. Sorry. And I'm going to use my pattern here. What's playing the role of A? And what's playing the role of B? It's just 5. All right, it's just going to be 5 playing that role because the negative gets thrown in with the signs. Okay? The negatives get thrown in there with the signs. If you use the pattern, that means you're taking this first term, which is 2x, cube it. That means it's 2x times 2x times 2x. Yes, ma'am? is minus b cubed. Thank you. I didn't realize I put another 3 there. I was getting 3 happy. Thank you for picking that up. Sorry about that, guys. Then I go to the next part. I have the minus 3 times the quantity 2x squared times the 5 plus a 3 times the 2x times the 5 squared minus a 5 cubed. Just a second ago, the reason why we were talking about exponent rules with distributive properties and stuff like that, jump cubed, if it's just the monomial, we have to send that cube part to both pieces, the 2 and the x. So we get 8x cubed. Shh, guys. What is 2 squared? What's 2x quantity squared? 4x squared. What's 3 times 5? 15 times 4. It's a number, 60 minus 60 x squared. 5 squared, 2 of those, 3 of those. And there you go. Sorcery. Now again, do you have to use the pattern? No. You can do the other method and just FOIL it out. It just takes longer. Okay? I would suggest get used to the pattern. I would at least try a couple of them. Okay? Try a couple of them with the pattern just to get accustomed to it. All right? Oh! What do you think the answer is on that? You're right. I mean, it's wishful thinking. I think I posted the problems already, didn't I? I did. Hopefully I counted correctly because I thought I did. I remember gluing the book going, it's 12 of them. There's a handful of each type. Add, subtract, and multiply. Like I said, tomorrow we will talk about factoring via grouping. It really won't look much different than what you guys have seen in the past. It'll just have an upper degree polynomial, which means you might have an extra step or two towards the end. I don't think we'll get to the zeros portion of it, but at least we'll work on the factoring. Okay? Well, that's right. Devin had that fire drill stuff today, so he was busy with assembly. Ladies and gentlemen, guys, you have time to start working. Start working, please. One second else, let me save this real quick.